Welcome to the YouTube channel Pcmb Tutorials. I hope you all are fine. Today we are going to learn class 9th chemistry chapter Metallurgy part 3. In this part we are going to learn the step 2, that is chemical change. So let us start. Step 2, chemical change. During this process, chemical state of the ore is changed. It involves the two processes. First one is conversion of concentrated ore to its oxide. Conversion of concentrated ore to its oxide. It is done either by calcination or roasting. Calcination or roasting. Calcination and roasting. So calcination means it is a process of heating the concentrated ore below its melting point in the absence of air, whereas roasting means it is a process of heating concentrated ore below its melting point in the presence of air. So only one difference is there. Calcination is process of heating in the absence of air, and roasting is process of heating. Roasting is the process of heating in the presence of air. Calcination is applied for carbonates and oxide ores. Carbonates and oxide ores, whereas roasting is applied for sulfide ores. And the result is, first, in physical change, volatile impurities and moistures are removed. Second, in chemical change, carbonate ores decompose into their respective oxides. Whereas in roasting, first, physical change, volatile impurities are and moistures are removed. And second, chemical change, sulfide ore changes into oxide. Let us see the reaction of calcination. ZnCO3 gives ZnO plus CO2. Calamine. This is calamine. And in roasting, 2ZnS plus 3O2 gives 2ZnO plus 2SO2 plus 2SO2, which is zinc blend. Zinc blend. Second process is reduction of metallic oxide to metal. Reduction of metallic oxide to metal. The metal oxide obtained from the previous step is converted into metal by reduction. The type of reduction depends upon the nature and chemical reactivity of the metal. The commonly used reduction methods are: first is electrolysis, second is reduction by reducing agents. First is electrolysis, which means electrolytic reduction. Second is chemical reduction, which is reduction by reducing agents. Reduction by reducing agents. And third one is heating. So these are the main process. Main process of electrolysis is electrolytic reduction. Reduction by reducing agent is chemical reduction, and heating is thermal decomposition. So electrolysis is the method. Fused metallic salts are reduced by electrolysis. The resulting metal ions get decomposed at cathode. Whereas reduction by reducing agents, the method is the oxides are reduced to metals by coke, carbon monoxide or hydrogen. Heating is the method. Oxides are reduced to metals by the action of heat alone. The electrolysis is applied for oxides and halides of highly reactive metals in activity series. Reduction by reducing agents is applied for oxides of moderately reactive metals. Heating is applied for oxides of less reactive metals having lower position in the activity series. Example of electrolysis is potassium, sodium, calcium, magnesium, and aluminium. Oxides of this. Whereas in chemical reduction, examples are oxides of zinc, lead, iron, and etc. In thermal decomposition, the examples are oxides of Hg and Ag. The reaction, we can say Al3 plus 3E gives Al at cathode. Al at cathode. Reaction of chemical reduction is ZnO plus C on heat gives Zn plus CO. Reactions of heating is 2HgO on heating of 300 degrees Celsius gives 2Hg plus O2. I hope you have understood till this. Let us see this step 3. Refining of metal. The process of removing impurities from the crude metal is called refining. Depending upon the nature of the metal and on the impurities present in it, following processes are used for refining. So, first one is liquefaction. Second is oxidation. Third is distillation. Fourth is electrolytic refining. So, liquefaction is used for refining metals having low melting point which are easily fusible but have non-fusible impurities. On heating pure metals, on heating over here liquefaction, pure metals melts and falls down along the slope of furnace, whereas impurities which are non-fusible are left behind. Sorry. In oxidation, for refining metals by oxidation of their impurities. Example is during extraction of iron, impurities such as phosphorus, sulfur, and carbon are oxidized by blast of air to their respective oxides P2O5, SO2, CO2. On oxidation, pure metal is left behind in molten state. Impurities are oxidized and escape as gases. In distillation, for refining volatile metals, example zinc, mercury. On heating, first we get pure metal vaporizes and is condensed and collected. Second, impurities which are non-volatile are left behind. Fourth, electrolytic refining. For refining metals by electrolysis on passing electric current, first pure metal is deposited at cathode and second impurities settle down forming anode mud. Then the small topic is precious impurity. So who would not like to have impurities having gold and silver? This is precisely what is happening in the refining of copper. The impurities settle down as a heap called anode mud. Below the anode, anode mud consists of traces of silver and gold. The impurities are as valuable or might be more valuable than the pure metal itself. In fact, the anode sludges from copper refining cells provide 1/4 of the US silver production and about 1/8 of US gold production. So let us revise the extraction of pure metal from ore. Ore has two types: dressing, in that crushing is first method and second is grinding. Ore gives powdered ore, which has second type, concentration. Concentration's first method is gravity separation, second is froth flotation, and third is magnetic separation. Then we get concentrated ore. Then we use calcination and roasting. We'll end up to metal oxide, to crude metal, which have reduction, electrolytic reduction and chemical reduction and thermal decomposition. Crude metal to pure metal we get refining, distillation, pooling, liquefaction and electrolysis. Pooling, or we can say oxidation. I hope you have understood till this. Our next topic is iron. General study, occurrence of iron, ores of iron, different forms of iron, extraction of pig iron from the hematite, different forms of iron, chemical properties of iron. But this we will learn in the fourth part of this chapter. I hope you have understood this part too. For any queries and doubt, please join the Telegram link given in the description of this video. Like this is the foundation of class 9th. We have covered the foundation of class 8th and 7th too. The links are given in the description. Please go and check through it. Let us meet in part 4. Thank you for watching.